In this video, we're going to calculate the magnitude for a vector. Now, magnitude is the size or length of a vector, and how we work it out, if we had a 2D vector here with components A and B, the magnitude is you use square A, square B, add them together and square root them, i.e. we're just doing Pythagoras to it. So let's look at this first example here. We've got V is equal to negative 3, 4. So the magnitude would be negative 3 squared, remember to put that in a bracket, plus 4 squared. So I need to square them. Negative 3 squared is 9, 4 squared is 16. Add them before I square root. So we get 25. Square root of 25 is 5. So the magnitude of this first one, V, is 5. Okay, let's look at the second question. 2a plus b, where a is 2, negative 1, and b is 5. So the first thing I need to do is work out what 2a plus b is. Okay, so that's going to be 2 lots of 2 and negative 1, plus 1 lot of 5 and 2. So we're going to get 2 times 2 is 4, 2 times minus 1 is minus 2, plus 5 over 2, 5 and 2, sorry. And then we've got 4 plus 5 is 9, negative 2 add 2 is 0. So that is the vector 2a plus b. So to work out its magnitude of 2a plus b, we do the square root of 9 squared, the first component, plus the second component, 0 squared. So we are going to have 9 squared is 81, plus 0 is 81. So that's 9. Now, last one here is this one over here. 2, negative 3, and 4. So we have 3 components, but I still do the same thing. So to work out the magnitude of this here, I am going to big square root. I'm going to do each of the components squared and then add them all together. So 2 squared plus negative 3 squared plus 4 squared. So 2 squared is 4, negative 3 squared is 9, and 4 squared is 16. If I add those all together, I'm going to get root 29, and I leave it as that as a